Welcome to a demo of using Kracken to cause chaos on an OpenShift cluster and measure its impact with Cerberus. Here's our Kracken configuration. We're first going to set any scenarios that we are wanting to run with any extra customized scripts or post-action checks that we are able to use to validate our components recovered properly. We set the Cerberus URL and we're going to check that to get the go, no-go status. We are also going to be running in daemon mode, which means that we would continuously cause chaos until Cerberus gives us back a no-go status to let us know the cluster is no longer healthy from the chaos we caused. This is an example of a pod killing scenario. Here we're going to be selecting 3 running pods in any OpenShift namespace with a probability of killing each at 70%. This is a custom script that we were able to use to check the number of pods that are currently running in all OpenShift namespaces. We use this as a before check to check the number of pods that are currently running, and then as an after check to be able to verify if the components had recovered properly. Now let's take a look at Cerberus and Kracken running. In the terminals here, Kracken is running on the top and Cerberus is running on the bottom. We have started Cerberus to get an initial health status of the cluster. Kracken is also starting and going to run the first scenario's pre-action check. Here we can see that our pre-action check returned that we have 148 pods that are running in any OpenShift namespace. Now Kracken is executing our scenario where it will be killing up to 3 of these pods, and Cerberus is continuing to check a variety of components. We can see that this killing has affected some other areas of the cluster. Specifically, some containers and pods in the OpenShift monitoring namespace are failing now. We will continue to monitor the state of the cluster while we pause the chaos to see if the components and overall health of the cluster recover properly. After the Kracken run has resumed, we can now see that the post-action script has also returned 148 running pods in the OpenShift namespace. This means that even though we have killed up to 3 pods, they have all restarted and recovered to a normal state. We have also received a go status from Cerberus that all the components we are monitoring are healthy, and this iterative test would continue. This is our configuration for the node chaos scenarios. We have 2 actions here that we will be injecting into our cluster. First, we will stop and then restart a worker node and then terminate a master node. Here we have decided to kill nodes based on labels that they have, but we can also kill a node based on its specific name. Currently, we have only added node scenarios for AWS, but we plan to support all other cloud providers in the future. You can refer to the README to see the full list of all possible node scenario actions. So now we are starting to run Kracken with only the node scenarios. In the top terminal is Kracken, and running in the bottom we'll be taking a look at the nodes and their states while Kracken is executing the scenario. First, we can see that Kracken is listing off all nodes that fit our label that we set up in the config file. Kracken is stopping a node containing the IP address of 128.93. We can see that this node originally had the status of ready, and after the node was stopped, the status changed to not ready. In the node termination scenario, we can again see that Kracken is listing out all nodes that fit into our label and the specific node that is going to terminate. The terminating node first goes into the not ready state before it is fully terminated and gone from our list of nodes. We can now go into AWS and see that this node that was in our cluster is now terminated. We hope that you were able to learn how to set up and run a scenario that you're able to get started on your own chaos testing with OpenShift. We would love any suggestions for expansion or help with this project to cause more chaos. Please feel free to open issues, take a deeper dive into the code and documentation, or work on any existing issues on the GitHub link. Thank you.